Take a look at this data center. For the past year, the default state of early career software portfolios has been to build basic front-end interfaces that route every user query to massive external server racks, exactly like this. That architecture, commonly called an API wrapper, presents specific infrastructure risks that many enterprise teams are now looking to eliminate. This diagram shows exactly why. When you send a data packet from a local interface to a cloud LLM, you introduce 3 distinct points of failure. Every request incurs a hard financial cost, an unavoidable spike in network latency, and a data privacy vulnerability the moment that packet leaves your network. To survive strict enterprise constraints, AI engineering is moving away from cloud dependencies. The industry is shifting toward localized edge computing. Simply knowing how to connect to a third-party cloud API is no longer a sufficient engineering skill. Mastering local, self-contained AI inference on your own hardware is the new baseline for professional value. Generative AI's initial development was dominated by the idea that a larger parameter count always resulted in a better model. But enterprise companies have found that leveraging a trillion-parameter cloud model to handle focused, single-purpose tasks is computationally wasteful. The architectural solution to this inefficiency is the small language model, or SLM. SLMs are highly optimized, compact algorithms. They are engineered to operate within the memory and processing constraints of standard consumer hardware. Comparing architectures, monolithic cloud models sit left. On the right, compact SLMs like 5.4 and Llama 3.2 slot directly into a laptop schematic. This closed-loop local pathway eliminates external network bottlenecks, granting near-instant latency and a private perimeter where data never leaves the machine. Migrating to SLMs gives you absolute engineering control over your inference pipeline, while reducing external API costs to 0. To build this, you need a localized execution layer to serve as the interface between the raw SLM and your hardware. Currently, the industry standard for this execution layer is Ollama. Ollama is a command line utility that allows engineers to download a model and spin up an active local server simultaneously. In this terminal, local deployment requires just one line of code. Typing Llama run 5.4 initializes the model and assigns a local port in seconds. For developers who prefer a visual interface over a terminal, the primary alternative is LM Studio. LM Studio provides a graphical user interface to manage hardware offloading. This feature lets you manually allocate specific layers of the model directly to your GPU or Apple Silicon. Both Ollama and LM Studio are OpenAI API compatible. This means your local servers format their requests and responses exactly like major cloud providers. These tools allow you to treat your local laptop like an enterprise cloud provider, bridging the gap between local compute and standardized API workflows. Any standard cloud-dependent AI application starts with a configuration designed to connect to an external server. These applications rely on environment variables to dictate where they send their data packets. The variable that controls this routing is the API base URL. In this code modification, we replace the external provider's URL with our local machine's address, localhost port 11434. The data packet redirects, connecting directly to your local Llama server instead of the cloud. The front end receives a perfectly formatted response, completely unaware the back end changed. You now have an AI workflow that operates without the financial drain of a continuous cloud subscription. Furthermore, this local implementation meets strict enterprise privacy constraints, as no proprietary information is ever broadcasted over the internet. Executing this single line of code reconfigures the application's entire data pathway, converting an expensive API wrapper into a private edge computing environment. With the technical implementation complete, we must address how to discuss this architecture during engineering reviews and technical interviews. Successfully deploying a local small language model is a critical baseline, but it is not the same as building a comprehensive AI system from scratch. The precise taxonomic reality of an Llama implementation is the execution of a localized, quantized neural network. This matrix illustrates the difference. A deep learning pipeline requires complex, multi-stage processing, including training phases, gradient descent, and data ingestion. Conversely, a basic network deployment focuses purely on inference execution, using pre-trained models with fixed weights. They are distinct concepts. These two architectures operate under entirely separate deployment and hardware constraints. Conflating these concepts during a technical interview carries a significant professional risk. Using the wrong terminology indicates to senior engineers that you have not yet distinguished between simple inference and complex model development. The era of the simple API wrapper is no longer viable for enterprise software development. Modern engineering value in the AI space is defined by 3 core competencies. You must be able to deploy, orchestrate, and govern these models locally. Your first step is to install Llama or LM Studio on your development machine today. Download a sub-10 billion parameter model like 5.4 and run your first localized prompt. Demonstrating local AI inference on everyday consumer hardware has become a core requirement for engineering at the enterprise edge.